Dear students, let's learn more about the chapter units and measurement. If you measure a value and if you do the calculation like 2 by 3, so use your calculator. If it is a 12-digit calculator and if you divide 2 by 3, the answer that you get is 0.666 like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the answer that you get to see in the calculator. And the question is, how many digits I have to restrict while doing the calculation? Is it 1 or 2 or 3 or 4? And that is what today's topic is all about. That's rounding off digit rules. So, restricting a number to certain number of digits is called rounding off digits. So, there are certain rules are to be followed while rounding off the digits, and then we have to decide well before how many digits that we are going to restrict. And here we are going to use our last concept. What is that? Significant figures is the most important before learning the rounding of digits. So, therefore, make sure that you have learnt the significant digits, that is the topic which I had explained in my last class. So, first to learn that, only then you will understand what exactly mean by rounding off digits. So, there are certain rules are to be followed while rounding off digits. So, what are those rules? So, first understand that there are certain rules are there. The rule number 1 is, if the digit to be dropped is lesser than 5, if the digit to be dropped is lesser than 5, the rule is the previous digit is retained as it is without modifying. Okay. So, I am going to give an example. Here there is an example. 1.344 is the number given. 1.344 is the number given, and it's also given that we have to restrict our answer to 3 significant digit. Okay, it's a given that you have to restrict the answer to 3 significant digit. So, if it is 3 significant digit, then this is the first significant digit, this is the second significant digit, this is the third significant digit, correct? That means this is the digit to be dropped. Okay, arrow down indicates that is the digit which have to neglect, which have to omit out of the number. Okay, so that is a digit to be dropped. If the digit to be dropped is lesser than 5, check this, this is lesser than 5, isn't it? So, this number is lesser than 5. If the digit to be dropped is lesser than 5, then all the previous digits are retained as it is. So, therefore, the answer is 1.34 for this particular number. Are you clear with that? So, that is the rule when the number is, the digit to be dropped is lesser than 5. Okay. We do have other rules also, just be patient to know if it is more than 5, if it is equal to 5, all that we are going to learn one after the other. Okay, so one more example. The number is 121.32 is the given number, and within the bracket it's given 4 significant digits have to retain. How many? 4. So, 1, 2, 3, 4. So, this is the digit to be dropped. All the digit after that are the digit to be dropped, even if there is one more digit, everything. But this is the next digit beyond which we have to drop. That means we have to neglect. Are you clear? Okay. Is it lesser than 5? Yes, it is lesser than 5. So, what the rule says? Retain all the previous digit as it is without modifying it. Okay. So, therefore, the answer is 121.3. I hope it's clear. Whenever the digit to be dropped is lesser than 5. Okay. Now, let's learn what if the digit to be dropped is more than 5. If the digit to be dropped is more than 5, then the previous digit is to be raised by 1. You have to increase the previous value, okay, by 1. If it is 3, make it 4. If it is 5, make it 6, correct? So, likewise, you have to go on adding one number to the previous, that is only if the digit to be dropped is greater than 5. That is the rule number 2. So let's see example for this, then you'll understand. Okay. Right, the example given is 1.346, 1.346, okay, that is the example given. How many digits we have to retain? 3 significant digit. So, most significant digit, this is the next second, this is the third significant digit according to the rule. So, this becomes the least significant digit, correct? No, because there are 3 significant digit, I have to retain it. So, that means this is the digit to be dropped, which is more than 5, you can check. Right, this is more than 5. So, what the rule says? Increase the previous digit by 1. So, therefore, the answer is 1.35 is the answer. Okay, right. The next one. So, one more illustration for that. It's a 421.38. How many significant digit? 4 significant digit. So, let's retain that 1, 2, 3, 4 significant digit. This is the digit to be dropped. Check that it's more than 5. The rule, increase the previous digit by 1, okay, that's the rule, okay. So, 421.4 is the answer, I have raised it by 1, okay. So, hope it is clear. So, these are the two cases where in one case the number is lesser than 5, digit to be dropped is lesser than 5, the other is a digit to be dropped is more than 5. If it is lesser than 5, retain the previous digit without modifying, and if it is greater than 5, increase it by 1, okay. Right. So, we have many other cases as well. So, let us see one after the other. Okay. Right. The next possibility, we have seen lesser than 5, we have seen greater than 5. Now, what if it is equal to 5 followed by non-zero digit? Okay. The number to be dropped is 5, but after that there are some more digits are there. If that is the case, raise the previous digit by 1, okay. So, you will understand what exactly meant by that. So, let us check this 51.457, okay, that is the example. How many digits have to retain? 3. So, 1, 2, 3, which is the digit to be dropped? Equal to 5, see, this is equal to 5, followed by non-zero digit, see, followed by some digit, any digit, non-zero, it is not 0. In that case, what is the rule? Previous digit is to be raised by 1. So, therefore, the answer is 51.5. So, this is the digit. Beyond this, we are going to drop the digit, okay, we are not going to retain it. We have to retain only 3 significant digit according to the example given here. So, and the digit to be dropped is equal to 5. It is not lesser than 5, so not more than 5, it is equal to 5. If it is equal to 5, then the rule is equal to 5 followed by some digits, that's the rule, okay. There has to be some digit after that, non-zero digit, only then the previous digit can be raised by 1, okay. Right, the next 1.3501, okay, how many? 2 significant digit, only 2. So, 1, 2. So, digit to be dropped is 5 followed by non-zero digit. See, these are non-zero only. This is 0, no problem. But here again, there is a non-zero digit. So, the rule is to increase the previous digit by 1. So, therefore, the value is 1.4 is the answer. Clear? Okay. So, let us go for one more case. So, one more possibility. What is that one more case? The case is equal to 5 followed by 0 or no digit. See, there is a difference between this and this. Here equal to 5 followed by non-zero digit, equal to 5 followed by non-zero. But here equal to 5 followed by 0, only zeros or no digit. Okay. In that case, again there are 2 possibilities. What are the 2 possibilities? In this case, you need to check. If it is equal to 5 followed by no digits, then check the previous digit, and if the previous digit is odd, if it is odd, then raise it by 1, and if it is even, okay, then there is no change in the value. Okay. What is that? If it is equal to 5 followed by 0 or no digit, I will give example, you will understand better. If it is equal to 5 followed by 0 or no digit, then check that the previous digit, and if it is odd, raise that same number by 1, and if it is even, don't change the value, you have to retain it as it is. Okay, right. So let us see the example to make things clear. 3.35 is the number given, 3.35. Okay, how many significant digit? 2 significant digit. So 1, 2. So digit to be dropped is equal to 5, followed by nothing, no digit. In the previous case, what? Equal to 5 followed by non-zero digits. Some digits are here, but in this case there are no digit. Got it? That is the difference between these two. Okay. Then in this case, what is the rule? You have to check one case, condition. What is the condition? Check where the previous digit, this is the digit to be dropped, right? So check the previous digit, whether it's odd or even. Is it odd? Yes. If it is odd, what is to be done? Increase it by 1. So therefore the value is 3.4. And if it is even, retain it. Okay. All right. So that example is here. We have 1.345 is the number. 3 significant digits are to be maintained. 1, 2, 3. So digit to be dropped is a 5, followed by no digit, or even if it is 0, the rule is the same only. Okay. Then we need to check the previous digit. We find that the previous digit is even, and since it is even, retain it without modifying. Therefore the answer is 1.34 is the answer. So hope you are following all these rules. So what are the questions possible from this topic? The question possibles are, they will give a number and then you are asked to round off the number. It's a 1 mark question. So for which you have to remember all these rules. Are you clear? Okay, so let's learn more about it. There are many more rules to be followed. Okay, and that rule is when the numbers are multiplied or divided. Okay, and the numbers are multiplied or divided. When the numbers are multiplied or divided, the number of significant figures in the result means, say, after multiplying we get an answer, correct? That is the result. In the result is equal to the least number of significant figures of any of the given values. Okay. So let us try to digest this entire statement. What is the statement? When numbers are multiplied or divided, the number of significant figures in the result, in the final result, how many significant figures we have to retain it, correct? Because in this case they don't tell you how many significant figures you have to retain. The rule is you have to retain in the final result, which is equal to least number of significant figures of any of the given values. See, first certain values will be given, like A 0.1, B 22, C, let me give 150 I will write. Okay. So I have given 3 numbers here, or let me, okay, no problem, let it be there. Now when I multiply A, B and C, I will get one answer, right? This is the result. This is the result. Correct? After multiplying A, B and C, I will get some result. In this result, how many significant digit I have to maintain? That is what the rule says. In the final answer, you have to maintain the least number of significant digit in the any of the given values. Let us check. How many significant digits are here? There is only 1. How many significant digits are here? 2. How many significant digits are here? There are 2. Hope you remember this. This is a number without any decimal, and in the non-decimal number, the first digit is the most significant digit and the last non-zero digit is the least significant digit. So that's why we don't consider this. So that's what is true. Therefore, now you can see in the given data, the least is this. What is the least? 1. not the number, I am not talking about the number, I am talking about the significant digit. So the number of significant digit in the given values is least, how much? It is 1. So that's why in the final result, you have to maintain only one significant digit and apply the rounding off rule, and then see that in the final answer there is only one significant digit. So let me repeat the statement. When numbers are multiplied, like this, when numbers are multiplied, the number of significant figures in the result, this is the result, is equal to the least number of significant figures of any of the given values. Are you clear? Okay, so let me give a example. This is while multiplying, it's applicable for multiplication as well as the division. Okay, I'll give example and you'll understand what is the meaning of this particular statement. Okay, so let's take one question and we'll simplify it. Okay, so A is given, the value of A is 1.25. okay, the value of B is 0.25. First I will measure the number of significant digit. How many significant digits are here? 1, 2, 3. 3 significant. How many significant digits are here? There is only 1. So which is the least here? This is the least. Therefore, now the rule is, in my final answer, when I do the calculation, I will maintain only one significant digit in the final answer. Okay, right. What we need to calculate? A and B is given. Then find A into B. Okay, let's calculate that. A into B. 1.25. 1.25 multiplication into 0.5. Okay. So if I make use of the calculator, you can use this calculator for this. 1.25 into 0.25, or without the calculator also you can calculate. Okay. See, 1.25 into half of 1.25, half of 1.25, okay, is 0.625. okay. You can verify that. Again, you can use the calculator and can check. It's 1.25 into 0.5, so that will be 0.625. That's correct. Okay, now this is the result. Okay, but the rule is you cannot write this as the answer. You know why? According to the rule, according to this rule, the rule is whenever we multiply in the final answer, I have to retain only one significant digit according to the rule. Correct? No, because the least is 1. So therefore 0.6. This is one significant digit. That means this is the digit to be dropped. The rule is when the numbers are multiplied or divided, the number of significant figures in the result, we got the result, correct. But how many digits to write, how many digits to maintain according to the rule? The rule is whenever we multiply, in the result should contain the least number of significant figures in any of the given values. In the given values, the least significant figure is 1. That's why I have to retain only one significant digit. So this is the digit to be dropped. If this is the digit to be dropped, okay, the rule, check this. The digit to be dropped is 2. The first rule. What is the first rule? When the digit to be dropped is lesser than 5. Check this, this is lesser than 5. Since this number is lesser than 5, the rule is retain the previous digit as it is. So therefore, the answer to this is 0.6 only. Because beyond this, we have to neglect. Why we have to neglect? And why this is the digit to be dropped? The rule is, in the final result, the number of significant digit should be equal to the least number of the significant digit in any of the given values. The given values are these, in that least is 1, so that's why maintain only one significant digit and neglect all the rest of the digit by applying the rounding off rules. Are you clear? Okay, now that's with the multiplication. Let's divide and then we'll see what answer do we get. Division. So I will take this A by B, division is A by B, so 1.25 divided by 0.5. So this is same as 1.25. 0.5 means it's half, right? So this goes to the numerator and it's get multiplied. It becomes 2.50. This is what we get. Okay, all right. Now check. In the final answer, there has to be only one significant digit, right? According to the rule. That means I have to maintain only this. So that means this is the digit to be dropped. Time to recall the rule. The digit to be dropped is equal to 5, followed by only 0. The last rule, fourth rule. And when it's followed by 0, again there are two cases. We need to check whether the previous digit is even or odd. And we find that the previous digit is even. And when it is even, retain the digit as it is. So therefore the answer is only 2. So therefore A divided by B is equal to 2. See, these are the rules which we follow. Keep in mind, which we follow. If at all they ask, if A is 1.25 and B is 0.5, then find A into B and B A divided by corrected to significant figure. See, this question should be there. They should ask like this, find the answer corrected to significant figure. Only then follow the rules. Otherwise, I will tell you how many digits you have to actually maintain while calculating the numericals. Are you clear? So, this is the rule to be applied only in the question if they mention that find the final answer corrected to significant figures, something like this only. Okay? Right. So, hope you have understood the multiplication rule and the division rule. What multiplication and division rule says that whenever numbers are multiplied or divided, this is applicable to any number of digits, okay, not only for 2 digits, any number of digits. When you multiply or when you divide, in the final result, the number of significant figures is equal to the least number of significant figures in the given data or given value. Clear? So, this is for multiplication and division only. Now, what if there is addition or subtraction? Okay. What if there is addition or subtraction? The rule is slightly different. The rule is here. See the statement. While adding or subtracting the number of decimal figures, see number of decimal figures in the result is equal to the least number of decimal places of any of the given values. Here we do not follow the significant rule. Here we have to concentrate only on the decimal figures, decimal places. Okay. So, the rule is whenever we add or subtract numbers, in the final answer the number of decimal places, decimal figures is equal to the least number of decimal places given in any of the values. Are you clear? Okay, let us see the example. So, that makes things clear. Okay, so again the question is A is a 1.25, B is a 0.5. Student, here remember you have to focus on the number of decimal figures, okay, not total number of significant figure. So, for example, in this the number of significant figures are 3, but that is not required here because we have to compare the decimal places. Okay, right. So, how many decimal figures are here? 1, 2, not the number of significant. So, the rule while multiplying and dividing is completely different from the rule when we add or subtract the numbers. Clear? Okay. So, how many decimal places are there? There are 2. Okay, 1, 2, 1, 2. Here it is. Here in this there is only 1. So, which is the least? This is the least. So, therefore, I have to make sure that in my final result, I am going to maintain only 1 decimal place. The rule says, not me. Okay, right. So, what is the question? The question is A and B are given, find A plus B. Okay, A plus B, and then find A minus B. So, A plus B, this is A plus B, 1.25 plus 0.5. Okay. So, add here 1.25 plus 0.5 is 1.75. That is what we get when we add. Okay. So, what is the rule now? This is not the final answer. This is the correct answer. When we add, we get number. That is true. but how to express in terms of the significant rule, significant figures. Okay, the rule is I have to maintain only one decimal place in the final answer. Okay, decimal figure. This is the digit, decimal point is here. This is the first decimal place, which I have to maintain. That means all the other digits are to be neglected. That means beyond that, the digit to be dropped is a 5, followed by no digit or followed by nothing. So this is the rule number 4. Whenever the digit to be dropped is equal to 5, again there are sub rules. The sub rule says check the previous digit and make sure that whether it's odd or even. We find that the number here is odd. So when it is odd, you have to raise that digit by 1. So therefore, the final answer is 1.8 is the correct answer. And you can see there is only one decimal place here in the final answer, because that is what the rule. The rule is while adding or subtracting, the number of decimal figures in the result is equal to the least number of decimal places of any of the given values. I hope it is clear. Let's do the subtraction. A minus B. 1.25 minus 0.5. So, I will get 0.75. 0.75 when you subtract 1.25 minus 0.5 is 0.75. So, what is this is the correct answer. Okay, but what is the answer by applying the rule? By applying the rule, I have to maintain only one decimal place, which is this. So that means that is the digit to be dropped, which is equal to 5. Again 5 followed by nothing. Rule number 4 again, check the previous digit which we found to be odd. So we have to raise it by 1. So therefore the value is 0.8. So this is how the different rules are applied while rounding off. So we have a few more examples. So we'll check that, we'll solve it. Okay. Round off the following numbers into two significant digits, very clearly given in the question. Okay, two significant digit, and express in terms of scientific notation. So, two significant digit and you have to express in terms of scientific notation. That's what the question tells. Okay, right. So, let's start. It's given 1, 2, 4, 6, 7.3. First, I will express in terms of the scientific notation. What do you mean by scientific notation? Scientific notation is nothing but shifting the decimal, correct? So, let's first do that. Here it is 1, 2, 3 and then 4. So, it's a 1.24673 into 10 to the power. We have shifted from here, see 1, 2, 3, 4. So, I have to write 10 to the power 4. Okay. So, now I have expressed in terms of scientific notation, correct? Now, I have to maintain two significant digit, two significant, 1, 2, that is it. The rest digit to be dropped. The digit to be dropped is equal to 4, lesser than 5, rule number 1. So, therefore, the final answer is, okay, what the rule says? The rule says whenever the number is lesser than 5, no change, retain the number as it is. So, therefore, it's a 1.24 into 10 to the power 4 is the correct answer for this first option. Are you clear? Let's go for the second one. First, as usual, we'll shift it and then we'll write in terms scientific notation. Okay, check here 1, 2 and then 3. So, 3.01 into 10 to the power minus 3, correct? No, because whenever the number is lesser than 1, the 10 power is always a negative. Whenever the number is greater than 1, the power is always positive. Okay. So, now scientific notations, we have done it, but I have to maintain two significant digit, 1, 2. So, that is the digit to be dropped. Again, same as the previous number. Digit to be dropped is lesser than 5. Rule number 1. Maintain the previous digit as it is. So therefore you have to write this number as 3.0 into 10 to the power minus 3. Are you clear? So you have combined the two concepts here. One, we have used a significant digit, rounding off rules, scientific notation, it's all in one exercise. Okay. Let's go for the next number. Okay, the number 3. There is a square root. Square root of 2.5 into 10 to the power 5. Okay, let me write that here. Square root of 2.5 into 10 to the power 5 is the number. See, students, one point which you remember, that whenever there is 10 to the power an odd number, okay, you make it even. How to make it even? This 10 to the power 5 is same as 10 to the power 1 into 10 to the power 5, correct? So I will do that. 2.5 into 10 to the power 1 into 10 to the power, not 5, 10 to the power 4. Okay. Now you multiply this 10 and 2.5. 10 into 2.5 is 25 into 10 to the power 4. Now it's very easy. Check this. Root 25. So what is the square root of 25? That's 5. Correct. What is the square root of 10 to the power 4? Square root of 10 to the power 4 is, you just write half of the power. If the power is 4, write 10 to the power 2. If the power is 6, 10 to the power 3. If the power is 8, 10 to the power 4. If the power is minus 16, 10 to the power minus 8. Half of that number, okay, when it is 10 to the power. If it is an odd number, you can't write. If it is 10 to the power 9, don't write 10 to the power 4.5. Now that's correct. But you have to make it, whenever it is odd, make it even by splitting that number. Okay, that's how you have to do it. Okay, so now what do we get? It's a square root of 10 to the power 4 is nothing but 10 to the power 2. But what the rule says there has to be two significant digits, but in this there is only one. So that's why I write this number as 5.0 into 10 to the power 2. See, now there are two significant digits are there. I hope you have understood the number. Okay, let's go for one more number. Square root of 2.5 into 10 to the power minus 5 now. Minus 5, okay. So 2.5 into 10 to the power minus 5. Okay. See how easily, now it's odd number again, correct? See how we can easily convert this into even. Okay, so that is 2.5 into 10 to the power 1 and 10 to the power minus 6. Can I write like this? Because minus 6 plus 1 is minus 5, right? Minus 6 plus 1 is 10 to the power minus 5. And see, now it's an even number. And 2.5 into 10 is nothing but 25 in 10 to the power minus 6. Square root of 25 is 5. Square root of 10 to the power minus 6, I have told you, whenever the number is even, just when you take the square root, correct, you will get exactly half. You know why? Because basically square 10 to the power minus 6, when we say square root, it means 10 to the power, it's a half. Square root is nothing but to the power half. And when you multiply, minus 6 into half is nothing but 10 to the power minus 3, right? So that's why I've told you, write half of the power. So into 10 to the power minus 3. But that is not our final answer. You know why? Because the rule or in the question it's given that you have to maintain two significant digits. That's why I write it as 5.0 into 10 to the power minus 3. Are you clear? Okay. So let's try one more question. It's root of 25 into 10 to the power 9. Okay, root of 25 10 to the power 9. As usual, we have to, it's already an odd number and I've told you how to do that. 25 10 to the power 1 into 10 to the power 8, correct? Okay. Square root of 250 into 10 to the power 8. What is square root of 250? it's a root of 250, root of 250. We'll get 15.81, okay, 15.81, that's what we get, square root of 250 into 10 to the power 8 means half of it, 10 to the power 4, 10 to the power 4, okay. So how many significant digits? 2 digits, there are already 4 are there, so this I have to maintain 2 digit 1, 2, this is the digit to be dropped. Check the digit to be dropped more than 5. When the digit to be dropped is more than 5, it's the second rule. Previous digit is to be raised by 1. So therefore, the number becomes 16 into 10 to the power 4 is the answer. Okay. So hope you are following and hope you have understood how to use the rounding of rules and then how to apply in the various cases or various numericals. Okay. So we'll learn more about this particular chapter in the next session. Thank you.